Hey team, I am absolutely pumped to walk you through this explainer today because we are doing a critical, no-fluff, technical deep dive into Retrieval Augmented Generation, or RAG. Specifically, we're talking about how to move RAG completely out of that fragile prototype phase into a robust, scalable production system. To set the stage a bit, think of a standard large language model, like a genuinely brilliant student taking a closed book test. You know, they have incredible general knowledge, but they obviously don't know the specifics of our company's proprietary data. Well, RAG transforms that into an open book exam. It literally allows the model to flip through our exact documents, pull the highly relevant facts, and generate an answer that is actually grounded in reality. So today, we're going to look at the actual architectural patterns that make this happen at a massive scale.
So, here is our roadmap for the session. 1. The RAG reality check. 2. Intelligent chunking and ingestion. 3. Scaling vector databases. 4. Routing and adaptive patterns. 5. Evaluation and self-correction. And finally, 6. Agentic, multimodal, and graph architectures. It's a comprehensive roadmap for us to really level up our AI systems.
Section 1. The RAG reality check. Dismantling the myths. Okay, let's just dive right in and confront some of those persistent industry myths head-on. Because there's this narrative floating around out there that RAG is broken, or worse, that RAG is dead. And honestly, that is just fundamentally incorrect. RAG isn't just one single static piece of technology. It's an evolving architectural pattern. What we're seeing right now isn't the death of RAG at all, but rather its maturation to handle real, messy enterprise complexities.
The other massive misconception we have to talk about is the idea that because models now have these million-token context windows, we can just bypass retrieval entirely. Like, if you can just stuff an entire database into a prompt, why even bother building a RAG pipeline? Well, context stuffing fails spectacularly in production. First off, infrastructure cost. Processing a million tokens on every single user query, that will bankrupt an IT budget in days. Fun fact, running maximum context windows on thousands of daily queries can literally cost more than your entire cloud hosting bill for the year. Second, you suffer from terrible query latency. Those calls are just painfully slow. And third, the research actually shows that models suffer massive precision loss when you just overload them with noise. A well-structured RAG architecture surfaces exactly what is needed, which drastically lowers our costs and our latency, all while keeping that signal-to-noise ratio incredibly high.
Section 2. Intelligent chunking and ingestion, building the bedrock. And that brings us directly to our ingestion pipeline, which is the absolute bedrock of a successful system. The naive approach to breaking up documents is fixed-size chunking, just slicing a document into arbitrary 500-token blocks. But this absolutely fails us in production because it breaks context at completely arbitrary boundaries. If a critical thought is just sliced right in half, neither resulting chunk is going to make any sense to the embedding model.
To fix this, we need to upgrade to semantic chunking, which uses an embedding model to dynamically detect natural topic shifts and break the text right along those conceptual boundaries. But to really dramatically impact our retrieval accuracy, we use hierarchical chunking. This is also known as small-to-big retrieval. It involves storing a small, highly precise chunk specifically optimized for semantic search. But, and here's the magic, when that small chunk is retrieved, we pass its much larger parent chunk to the LLM. This gives the model the exact hit for accuracy wrapped up in the broader context it actually needs to synthesize a truly great answer. Luckily for us, we don't have to build all these complex chunking logic systems from scratch. Production frameworks like LangChain and Llama Index have fantastic built-in support for both semantic chunking and document-aware chunking. And document-aware chunking is absolutely vital for us when we're dealing with structured enterprise PDFs that rely super heavily on headers and markdown. Oh, and just a quick reminder for the team, as we build this out, always ensure you are benchmarking your specific embedding models, whether we're using an OpenAI model or an open source option from Hugging Face, directly on our specific domain data.
Section 3. Scaling vector databases. Infrastructure selection. So, the crucial point here is once we have these perfectly chunked and embedded documents, where are they actually going to live? Let's pivot to the infrastructure that will house our vector embeddings.
When we're selecting our vector infrastructure, we really need to carefully weigh our options, particularly between fully managed solutions like Pinecone and open-source giants like Milvus. If our number one priority is pure query latency at scale with basically zero maintenance overhead, Pinecone's fully managed architecture is incredibly fast and just drops right into our stack. However, if we're handling tens of millions of vectors and we need highly granular control over metadata filtering and raw infrastructure costs, standing up Milvus on our own clusters might actually be the better play.
Ultimately, both offer the vital hybrid search support we need to seamlessly combine semantic vectors with traditional keyword searches, which is a must-have for things like SKU numbers and highly specific company acronyms.
Section 4. Routing and Adaptive Patterns. The Maturity Ladder. Okay, now that our infrastructure is set, we can start climbing the actual RAG maturity ladder. We are officially stepping past simple RAG and RAG with memory, which, don't get me wrong, are great for prototyping. But we're moving into much more complex routing and adaptive patterns that can handle real, messy user unpredictability.
The first advanced pattern here is branched RAG. You know how often a user will ask a complex multi-part question that a single database query simply cannot fulfill? Branched RAG handles this beautifully by placing an LLM step at the very beginning to decompose the user's question into multiple, distinct subqueries. It then runs parallel retrievals for each of those subqueries simultaneously and finally synthesizes all those separate retrieved facts into one coherent answer. It is a massive leap in capability for handling complex user prompts.
Then we have adaptive RAG. Think back to the infrastructure cost and latency trade-offs we talked about earlier. If a user asks our bot a simple greeting or a really basic math question, hitting the vector database is just a complete waste of resources. Adaptive RAG introduces a lightweight classifier or routing layer right at the front door. This router decides if a query needs full retrieval, simple retrieval, or absolutely no retrieval at all. By skipping the database entirely for simple queries, you directly lower your latency and save significant API and compute costs.
Another truly fascinating pattern is HIDE, which stands for Hypothetical Document Encoding. This solves a really massive issue, the semantic gap. A short user question like, "What causes inflation?" looks very different mathematically from a dense, 3-page document explaining the economic theories of inflation. HIDE bridges this gap by first asking the LLM to generate a hypothetical, basically fake, answer to the user's question. We then embed that hypothetical answer and use it as our actual search vector. Because the hypothetical answer looks structurally much more like our target documents, our retrieval quality and accuracy absolutely skyrocket.
Section 5. Evaluation and Self-Correction. Quality Gates. As we continue moving up this maturity ladder, we enter the realm of systems that actively police themselves. Because hallucinations often happen not because the model is broken, but simply because the retrieved data was bad. We need quality gates.
Enter Corrective RAG, or CRAG. This pattern acts as a sequential pipeline step to address the very real failure mode of low-quality or irrelevant retrieved documents. Once documents are retrieved, CRAG actually evaluates them against a strict confidence threshold. If the documents score too low and are deemed irrelevant, the system absolutely refuses to just guess. Instead, it will autonomously reformulate the search query and try again. Or it'll execute a fallback to a general web search to find better context before it ever attempts to generate that final answer.
Taking that even a step further is self-RAG. Now, while CRAG evaluates the documents, self-RAG prompts the LLM to continuously evaluate its own reasoning in real time. It does this by generating specific reflection tokens right alongside its text. It literally asks itself mid-sentence, is this passage actually relevant to the prompt? Or is the claim I'm making right now actually supported by the context I just retrieved? While this is obviously more complex to implement in terms of latency, it is incredibly powerful and frankly necessary for high-stakes enterprise applications where hallucination just simply isn't an option.
Section 6. Agentic, Multimodal, and Graph, the cutting edge. Let's move to our final section and see how all this builds into the most advanced design patterns driving the entire field right now. This is where we break out of traditional text search entirely.
Let's be really explicit about the technical difference between simple RAG and agentic RAG. Simple RAG is a strictly linear pipeline. Retrieve the documents, stuff them into the prompt, and generate an answer. Agentic RAG completely changes that paradigm. The LLM becomes an active orchestrator. Instead of a single step, it enters a reasoning loop. It decides what to do next. Maybe it needs to execute a SQL query, then call an external API, trigger a web search, and then evaluate all that mixed context. It loops continuously until it's satisfied it has the full correct answer. And again, frameworks like Llama Index Workflows and LangChain are purpose-built right now to support these multi-step agentic orchestrators.
And this brilliantly illustrates our next pattern, multimodal RAG. Let's be honest, real-world enterprise data is heavily visual. Think about asking a system to analyze a Q3 earnings report. The system needs to read the text, sure, but it also has to extract accurate numbers from complex bar charts and dense financial tables embedded way out on page 4. Multimodal RAG processes this reality by utilizing vision language models to generate rich text descriptions for images right at ingestion time. Or even more advanced, it stores native image embeddings directly alongside the text embeddings. Llama Index actually has native support for this, allowing our system to retrieve a specific diagram just as easily as a standard text paragraph.
Now, just imagine a user asks our system this exact question. How does this new regulation affect the contracts that we signed with these 3 specific vendors? A standard, flat vector database is going to seriously struggle with a highly interconnected query like the one we just read. Standard databases just look for semantic similarity. But GraphRag builds a dynamic knowledge graph right on top of your documents. It explicitly maps entities, like the regulation itself, our company, and those 3 specific vendors, and then explicitly maps the relationships between them. For complex multi-hop reasoning tasks in real-world industry applications, GraphRag dramatically outperforms standard vector search because it actually understands the structural network of your data, not just the vocabulary.
We have covered immense ground today, everyone, from the foundational bedrock of semantic chunking all the way up to the absolute cutting edge of graph and agentic orchestration. We've seen exactly how these patterns reduce our costs, lower latency, and dramatically improve accuracy over those naive prototype approaches. So I want to leave you all with this final challenge as we officially move out of the prototyping phase. Look at your current projects. What is the very first Agentic RAG workflow you plan to architect and implement in our next sprint? The tools are here, the patterns are clear, let's start building.